Hi everyone. Good morning, and good afternoon, good evening, whatever time zone you are in. I hope you are all healthy. First of all, let me thank you all for coming here today. I think I have 45 minutes, so I will try to stick to it. The target is talking to you about Oracle Database Resource Manager. I will try to get all of you to full Oracle Resource Manager at the end. And please stay with me. So, about me quickly, I am ARSALAN Dehghani. I have been working at Oracle database for more than 8 years. I'm Oracle Ace. I blog from time to time. I also spend way too much time on Oracle Forum, especially my Oracle support community. I'm still there. I'm trying to help and learn from the community and support each other. And now let's dive into the topic. Okay. I'll tell you about Oracle Resource Manager feature concept. So looking at the advantages of the Oracle Resource Manager. I'll tell you about the Oracle Resource Manager elements, managing and testing Resource Manager. I'll talk to about Oracle Instance Caging, Monitoring Resource Manager, Oracle Resource Manager enhancement in Oracle new feature, final equation answer. Okay. Using the Oracle Database Resource Manager, you have more control over the allocation of machine resources that usually is possible through operating system resource manager alone. If the operating system makes resource management decision, it can lead to problem such as excessive overhead. Excessive overhead resulting from operating system context switching of Oracle database server processes when the number of server processes is high. Inefficient scheduling, such suspension of Oracle database server process that is holding a latch. Another problem, unequal distribution of resources among all Oracle database processes and an inability to prioritize one task over another. The inability to manage database-specific resources, such as parallel execution servers and active session. I now like to move on the next part. Resource Manager control the distribution of resource amongst the various sessions by controlling the execution schedule inside the database. By controlling which sessions run and for how long, the resource manager can ensure that resource distribution matches the plan directive and the business objective. With the database resource manager, you can guarantee groups of users a minimum amount of processing resources regardless of the load on the system and the number of users. Okay. Turning our attention now to the resource manager elements. In this slide, the below outlined a few of characteristics of the resource plan. First of all, it can be activated at the database instance level using the resource manager plan parameter. It can be enabled dynamically by using the alter system command. Secondly, a database can have multiple plans defined or created by only one can be active at a given time for each instance. It is particularly used for situation value database that need to operate differently. For example, during the night windows batch processing, you want to allocate resources. My next point, which is specific for rack environments, this outlines that can be a different plan enabled per node or instance. Resource plan don't impose a hard limit, meaning if there is no other session is taken resource allocated, then this session can take all the available resources and not just the limited allocated. Resource plan can be associated with scheduled windows or jobs. So integration with Oracle Database Scheduler, DBMS Scheduler is possible. Okay. The second component is the resource consumer group. The resource consumer groups group users or sessions together based on their processing needs or the business requirements. One group may contain many users, and one user may be a member of many groups, but at any given time, each session will have one group as each influential group. The following session mapping attributes are the most commonly used for creating consumer group mapping rule. Mapping rules are used to automatically place sessions into a consumer group. First of all, and the most commonly used is based on an Oracle username. The second mapping attribute is the service name. So we can assign sessions to a consumer group based on the service name used to connect to the database. Another attribute, client OS user, client program, client mission, module name, module and action name, service module and action, and Oracle function. And RMAN or data pump operation, for example, valid values are data load, backup, and copy. There are predefined mapping for each of these values. So if your session is performing any of these functions, it is automatically mapped to a predefined consumer group. So to resolve conflicting mapping rules, you can establish a priority ordering of the session attributes from most important to least important. Another element is resource plan directives. Resource plan directives are added to a plan in order to determine how specific resources are allocated to the associated consumer groups and to the concurrent session that belong to those groups. Available directives, CPU method, degree of parallelism, active session pool, ideal time limit on the generation, program global area, and automatic consumer group switching based on execution time, IO limit, and IO request. Okay. One attribute is CPU method. To manage CPU resources, the resource manager allocate resources among consumer group and redistributes CPU resources that were allocated but were not used. Okay, you can also limit the number of CPU resources that can be allocated to a particular consumer group. This method can specify management method that can define how CPU resources are allocated among the consumer groups and subplan. Okay, so management attributes enable you to specify how CPU resources are allocated among consumer ground subplan. So multiple plans, multiple levels of CPU resource are allocated multiple levels of CPU resource allocation provides a means of CPU usage within a plan. For example, consumer groups and subplans at level 2 get resources that were not allocated at level 1 or plan, okay? But were not completely consumed by a consumer group or subplan at level 1. Similarly, resource consumer at level 3 are allocated only when some allocation remains from level 1 and 2. Okay, the same rules apply to levels 4 through 8. Use the management attributes MGMT, MTH, where MGMT PM, where n is an integer between 1 and 8 to specify multi-level of CPU resource allocation. So you can specify value for the resource allocation method when creating the resource plan. There are two ways of specifying the CPU distribution with the MGMT, MTH parameter when you create a resource plan. So the two operations are emphasis and ratio. Instead of percentage, you specify numbers corresponding to the ratio of CPU that you want to give to each consumer group. To use the ratio method, you can the MGMT, MTH argument for the current plan procedure, the ratio. Table in the slide show you different between two methods, emphasis and ratio methods. So in this slide, the below outlined a few of the characteristics of the degree of parallelism. First of all, it allows the administrator to manage parallel SQL operations. So it can be used to limit the number of parallel processes of individual statements, especially useful in a data warehouse, useful in the very large database environments. The degree of parallelism specified in the parallel clause of a table or an index takes effect only when parallel degree policy is set. Use the parallel degree limit P1 directive attribute to specify the degree of parallelism for a consumer group. Okay. In this session, in this slide, active session pool, the active session pool method of the resource manager lets the database administrator limit the number of statements that will run concurrently for one group without restricting the actual number of logins. An active session is defined as a session that is running a query or as a session that is in an uncommitted transaction. By default, a session will be queued identifiably but you can set a time if you wish. If a session from the pool is not available within a limit, the statement is aborted and an error is returned to the session that issued it. Okay. Avoid overloading the system with too many processes from a particular group at one time. Note, if a parallel process has been enabled, the parallel processes do not count against the session pool. Instead, the entire parallel operation counts as one active session. So by default, the session will be queued, but you can set a time limit if you wish. If a session from the pool is not available within this limit, the statement is aborted and an error is returned to the session that issued it. Sessions that are not doing anything every session consists on the server side of a server process and a PGA. Even if the session is not executing a statement, the operating system must still bring it onto the CPU according to its round-robin time slicing algorithm. This is known as a context switch. Okay. Every context switch forces the computer to do a lot of work as registers are loaded from the main memory. So the state of session checked, and then the registers cleared again. So the resource manager can discuss sessions that are not working according to target. The first is based on idle time. So how long it is since the session executed statement. The second is more sophisticated. It checks how long a session ran a statement and whether the session is holding any record or table locks blocking other sessions, which is a much more problem. So using the resource manager, you can configure automatic killing of any session that block other sessions for more than a certain length of time. It is possible to disconnect sessions by using Oracle profiles assigned to named users, which can you must enable with the instance parameter resource limits. However, the resource manager is a better tool for this. An important point is that the idle time is time their server process has been idle, not time that the user process has been idle. And let me use a graphic to explain this. Okay. Under pool or undo generation, you can specify an undo pool or each consumer group. And undo pool controls the total amount of undo for uncommitted transactions generated by a consumer group. When the total undo generated by consumer group exceeds its undo limit, the current DML statement generating the undo is terminated. So no other consumer group members can perform further data manipulation until undo space is freed from the pool. It's useful to prevent poorly writing applications, SQL statements, or database resident program units. Okay, in the next slide, program global area. Oracle has a long history of improving the management of the process global area. To manage PGA resource manager can limit the amount of PGA memory that can be allocated to each session in a particular consumer group. To limit the PGA resources for each sessions, the session PGA limit parameter has been added to the create plan directive and update plan directive procedures of the DBMS resource manager package. This new parameter specifies the upper limit in megabyte for PGA usages by a session assigned to the consumer group. So if a session exceeds its limit, an error is raised. Or error in slide. Okay. So before you enable the resource manager, you must specify how user sessions are assigned to the resource consumer groups. Okay, you can configure the resource manager to automatically switch a session to another consumer group when a certain condition is met. Automatic switching can occur when a session attribute changes. So causing a new mapping rule to take effect, or a session exceed the CPU physical I/O or logical I/O resource consumption limits set by its consumer group, or it exceeds the elapsed time limit by its consumer group. So, I'll possible to move session proactively using estimate feature setting. Okay, for example, if switch estimate set to true, the database estimates the execution time of each call, and if estimated execution time exceeds switch time, so the session switch to switch group before beginning the call. Default value for this parameter is false. So the execution time estimate is obtained from the optimizer. So the optimizer is the accuracy of the estimate is dependent on many factors, especially the quality of optimizer statistics. And in general, you should expect statistics to be no more accurate than 10 minutes. In addition to switching consumer group, the create plan directive procedure can be used to automatically cancel a SQL statement or kill a session if it exceeds its switch time limit. To achieve this set, the switch time should be set as normal, but the switch group should be set to cancel SQL or kill session instead of a consumer group name. Switch group specify in consumer group to which a session is switch if switch limit are met. If group name is cancel SQL, then the current call is canceled when switch limit are met. If group name is cancels SQL, then the switch for call parameters will always set to true, overriding the user. Okay. Consumer group mapping. For example, the simple resource plan is use is if you use for resource manager and have up to 8 consumer group and need only CPU resource allocation to control, then plan the uses emphasis CPU allocation policy by default, and each consumer group use the round-robin scheduling policy. So for switching between this plan, you can use consumer group mapping. Consumer group mapping assign an initial resource consumer group. So DBA can use the set consumer group mapping procedure to map a session attribute value paired to a consumer group. Determine which consumer group a session belong to at a time of logging. For example, when you not set consumer group mapping, automatically Oracle set predefined consumer group map to this consumer group. So prioritize the session attributes from most important to least important is used to resolve conflicting mapping rules. This procedure is set consumer group mapping PRI. Okay. Explicitly switching consumer group can be done with the following package procedure: DB session, switch current consumer, switch consumer groups, and switch consumer group, grant switch consumer group procedure. Okay, this presentation, this is like simple resource plan. The following PL/SQL API block creates a simple resource plan with 2 consumer group. Each consumer group specified in the plan is allocated its CPU percentage at level 1 and 2. Okay. Also, implicitly included in the plan are sysgroup. Sysgroup is a system-defined group that is the initial group, consumer group for Oracle Power User like sys and system. And other group, this is the sysgroup consumer group is allocated 100% of the CPU at level 1. Other groups is given 100 CPU at the level 3. So the great complex plan procedure create a pending area, create, modify, or delete consumer group, map session to consumer group, create the consumer resource plan, create resource plan directive, validate the pending area, submit the pending area, specify a plan to be used by the instance, create a consumer complex plan procedure, two step. One step is create pending area, grant permission to
Arsalan, we know you have lots of slides and experience to share with us, but actually the time's up. Can you just wrap up for 5 minutes and
I
summarize
this,
and wrap up in 5 minutes? And
my time is spent because my connection is disconnected, my internet issue.
yeah, it's okay. I mean, you have 4 or 5 minutes to wrap up, and in 5 minutes you can just finish the presentation if you can. Okay.
Okay.
Thanks.
Thank you for listening to me, and thank you to all.
Yeah, actually, if you have few slides, you can wrap up in 5 minutes. You still have 5 minutes to finish the presentation. Okay.
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 Can you see a slide?
Yes, we can see slides. If you want to give an important message in 5 minutes, you can just give that information, and then we can finish. Okay.
Okay. So. Sorry, as I couldn't present the scenario for this. So last slide is my instance caging, manage CPU allocation on multi-CPU server for multiple database instance. For enable, you need to use using CPU count parameter used to limit CPU consumption and a multi-CPU server with multiple database. CPU instance caging has a two method, or provisioning or partitioning, or provisioning some of CPU is for all instance exceeds actual CPUs on the server. Partitioning of CPU is equal to actual number of the CPUs server. First method, one database instance can still impact the others. For example, with all 4 instances active. One instance can get 25% of the CPU. Second method, partitioning. One database instance cannot impact the others because each instance has a dedicated number of CPU. For monitoring, you can use with Allocation, RSRC consumer group, RSRC plan. And for historical, DBA HistRSCR plan, DBA HistRSCR consumer group, plan history, cons group history. For the tuning, you can use with RSRMC MGRM metric, RSCRC MGRM metric history. Enhancement features in 90C, resource manager automatically enabled for database in memory, available fit database in memory feature, and secure QR entering excitingly. This feature can block SQL statement with bad execution plan. References database administration guide document, blog.oracle.com, and MIS note. Thank you for listening to me. Any question?
Thank you so much, Arslan. Thank you for this presentation.